Hello everyone, my name is Andreas Radischewski. I'm actually architect and engineer. So that's me actually. As you can tell, we have a lot of fun while working. So I'm in the BIM modeling since 2009. I worked a little bit in the Asian market in Sydney, was Bagot, the general planning over there, and tried to actually start with Revit in the BIM environment and then move from the closed BIM environment to an open BIM environment. So I'm working for Xella. Xella is a building manufacturer, so what we do is blocks, ceilings, irrigated concrete, calcium silicate, and today I'm going to show you how we actually work together with our clients on large-scale projects and how we can actually make all the processes better through BIM. So, and our main goal is actually not to use a certain technology, but to use open BIM. So we always rely on IFC, and typically, currently it's IFC 2.3, so we are not on the latest because of some issues we experienced. And my topic for today, like the broader topic, is the future is larger than 5D. What does this mean? So basically, we don't only looking at the planning stage, because then we're actually doing too much work. It doesn't really make sense just to focus on planning stage. We need this model to actually do some analysis, to take it to delivery, to take it to production. This is stuff I will show you how we actually deal with it, and then take this model back to the construction site and solve our issues on there. So what in the beginning of the digitization, when I started 5.5 years ago, actually we had a look at the customer journey and then where can we help with the models? And we were always modeling inside of our company since 2010. We have large formats like precast, where we really need to do the planning, where we have to structural calculations as well. We have structural engineers in our team. And then we basically take a look at the entire value chain. Where can we help our customer, our digital customer, with the models? So what we figured out that everyone has actually a different language. Even we are all modeling and we all like exchanging models with the IFC 2.3. There are still a lot of issues because everyone has their own standards, sort of. So what we have taken from the colleagues from Netherlands, they have something that is called the IDS. It's already translated in 22 languages, even in Chinese they use it. So it's a very common 2 A4 sheets page where you basically define what's the most important, let's say, target is of BIM modeling. So let's start with the basic one. So where is a BIM model situated? So all about coordinates. You always have to have the same coordinates when you actually clash models together, right? So, and then there is a little bit brighter ones like classification. That's a bit complicated. But then if I have a wall, how do I actually define all the parameters? So is it load bearing? Is it not load bearing? Stuff like this sounds pretty basic, but every architectural office and every developer is actually treating it a little bit different. So that's why we actually use those 2 pages to communicate. And this is like a rule set. It's called information delivery. And if you're interested in it, it's free to download for everyone. I think you can have it in different Slavic countries. I think it's even in Polish. We have Czech and Slovakian as well. So just to not be too theoretically here, I'll just go into some reference project for you, just to show how it really works. So we have a project from Germany now. It's in Dortmund, Germany, Kronprinzenviertel. For us, it's quite large scale. It's 600 units. It's a construction time of 3.5 years. And we have a lot of brickwork, which is delivered by us. So what we actually asked the client, are you planning in BIM? And they said yes. So we started to actually get their first model. So on the left-hand side, you see the first client model. And then down below the architectural model, we've done some analysis. So what kind of material has he actually specified? And was it the right material? Did it actually meet the requirements, the state requirements? requirements, the standards, and we communicate through IFC 2.3. It's the coordination view 2.0, if you're interested in this, so building smart standard. And then the client gets this actually back via BCF. BCF is a standard that you can actually upload into Revit, Allplan, ArchiCAD, all the main programs. And then it actually leads you to all the issues that we identified and shows you. And we're not only talking about architectural advice, structural advice, but we're talking about BIM advice here as well. So we're having a lot of BIM colleagues here who are actually taking a look at the quality of the model, because what we want to do, we want to make sense of it in every single stage of the building phase. So once we have analyzed it and we've sent it forth and back with a client, the next step for us, we use a program that is called Simple BIM. We actually get rid of all the elements that we don't need. So once we've understood the construction, we go with Simple BIM and only get the elements that we need for our production. So next step is actually starting to identify our details. And this is all done by an algorithm. So next step is here. So it's all a walling tool. And we basically do a segmentation here. And then we get all the lintels, all the mortar, all that kind of stuff. And then we really go into detail. And if you're wondering, maybe in some countries we're actually not using large formats, but in this case it's a German project and we have meter elements here, and all the ones that are actually that have detailed numbers are the ones that are tailor-made for this project. So you end up with a bill of material and you with a very detailed wall, and we then take this model back to the customer just to identify whether there is clashes in his planning and obviously for the construction site we need a drawing because they still operate in 2D, they still need their sheets to actually build from. So how have we used more of the parameters? So we talked about 3D, and then 4D is another one that we used here, because you can imagine like in a construction site like this, and this is only the first phase, we can if we somewhere here, we deliver 60 trucks in a week, 60 trucks. It's 15 cubic meters per truck. So we have to coordinate this. And this is how it helped us. They actually divided the building parts into phases. And then each phase has obviously a story and then a wall number. And this is how we actually like close it down to each single lot and each single delivery. So what you can see now is a picture of the construction site. And we always do some kind of, I still call it pilot project. We use the HoloLens already since 2018. But I'm not really convinced yet, because we still have some positioning issues here. And if you're interested, that's the Trimble version of it, and we use it together with Trimble Connect, just to make some quality control of the masonry work. So this is another step actually to the construction site where we can bring it. And still, if you're interested in the IFC, it's still the IFC 3.2, Coordination View 2.0. So let's not only talk about large-scale projects. This is a smaller one where we actually try to even take it further a little bit, the coordination with a client. So again, this is an architectural model by the client, so already very detailed. So all the structural work is in there. It's a semi-detached house for 2 families, quite small project, but this one actually gets built 150 times. And this is where BIM really makes sense. So if you have type houses, even if it's so small, then you define all the walls, all the details once, and you actually copy it. And what we've done here with a client, we actually decided that the load-bearing walls are on the perimeter. So each client can actually decide whether they want, how they want to make their internal walls. So all the load bearing is on the external part. On the outer part, we actually have large panels from Yutong, so it's irrigated concrete. And in the middle, there is calcium silicate because of acoustical reasons. So and here we actually detailed that far that all the masonry work was only done for this project. So it's all cut elements, as you can tell here, for the roof. And even the windows were prefabricated, and they were mounted by the same company, so by the builder and not the window manufacturer. So it's the same principle. They've mounted everything the same way. And because these are buildings that we actually built a lot, even before we used BIM, we could actually compare what was the efficiency gain. So what have we done here? 1 day per floor, obviously without ceiling and without foundation. So for 2 units and 1 day per floor. And actually, what is really good, the windows are already in there. They're a little bit protected, but it's all closed. So once they start to actually erect the precast ceilings, the entire floor plan is already closed. So it took us 12 days savings compared to typical construction. And we saved for one building 190 working hours for the masonry worker. And then comes another dimension, and this is something, so if we talk about environmental and sustainability, BIM can really help us, because BIM is a quite good database. So if you really go for it and you use the IFC, you can even export environmental product declaration units. And this is why in the future, the BIM models will be some kind of database for environmental friendly products. And then you can even analyze your projects. And I've just have a small example here. So I'm not entirely sure if you know the EPD. So it's Environmental Product Declaration. In Germany, we need it to actually declare how much CO2 emissions a product that has, how much water consumption we have, and is it recyclable? And then this one is actually divided from A to D. So this is like supply chain, production. This is the use stage when you actually live in there. And then you have the end of stage where you actually demolish. And some elements that are actually recyclable have obviously a minus value over here. And how you can actually use this, so we started with one of our installation material. We get the data into the objects. And then you can run your schedule in Revit. It's pretty easy. And then for all those factors, sorry, I was too fast. You can basically get your CO2 emissions. You can get the water consumption and even how recyclable it is. And so we got more and more clients asking for this, for example, like Deutsche Bahn, very important. And some of the materials, even after recycling, can still gather CO2. We call it recarbonation. So that's quite good to have it inside of the objects. And I think this will be requested more and more in the future. So I was a bit quick, so you have some more time to ask some questions. Thanks a lot.